Well, I did my honours. Was indirectly astronomy, and that's where some of my early work was in. It was in signal processing. I had a board that had been designed by a chap in Harvard. His name was Paul Horowitz, and it was a spectrum analyzer, and it was a new digital technology. It actually used some chips developed by the CSIRO that did fast Fourier transforms. So I built an interface for this board, and I evaluated its use of the board. So that was my honours program. So there was some physics in that, but mostly engineering. As it were.
Okay.
Yeah.
So you've kind of mentioned a couple of things that I think need unpacking.
Yep.
So it was a spectrum analyzer. So
Yes.
that's just looking at, for the guys who don't have a physics background or science background, it's just looking at all the colours in the light.
Yeah, and in this case it wasn't for light, but it could have been. In this case it was for radio signals. So it was attached to a radio telescope, and we were looking at radio frequencies, not at optical frequencies.
Okay.
Yeah.
And you mentioned Fourier transforming.
Yep.
So that's just breaking down the signal into its basic fundamental components.
That's right. Well, it just breaks it up into its spectrum. So if you have a time signal, then you can see what that time signal is, what frequency components make up that particular time signal. So the easiest way to think about it is like getting the white light, passing it through a prism and seeing all of the colours that make up that white light. The colours represent the different frequencies,
Right.
and the intensity is just how much of that particular colour is present. So in this case here, it's a radio signal, and you're breaking it up into its component frequencies and the proportion of each of those component frequencies.
Right. And what would that enable astronomers to do?
Well, in this case, what this board was meant to do was look at narrowband signals. So it's like having a stack of radios all tuned to a slightly different frequency, and seeing just how strong a particular signal is in any of those given frequencies. And it was developed to do a thing called SETI, the Search for Extraterrestrial Intelligence.
Oh.
So it wasn't to do any standard astronomy, because we're usually looking at broader band signals. This was narrowband signals. Yeah.
Okay, so broader band, those are the frequencies that
It's spread out over many frequencies.
Right.
Instead of having a lot of energy just concentrated in one or a few frequencies.
Right. And so when you're looking for extraterrestrial life, why would you focus on a narrowband frequency?
Well, I guess the idea was that we've developed radio, and radio in our case works by putting a lot of energy in a very narrow band of frequencies and transmitting that. So I'm talking about AM radio or FM radio, that sort of thing. And if you want to communicate over very long distances, it's very hard to actually travel those long distances, but it's very simple and cheap to send a radio signal across the galaxy.
Right.
You just need some energy, not a lot of it, and then time, and the signal will travel at what we think is the universal speed limit, the speed of light, basically.
Right.
So if you're looking for if there are other intelligent beings out there that have discovered the same physics we have, then if they want to communicate, maybe they'll do it in the same sort of way. So you're looking for those narrowband signals, and also we don't know anything in nature that creates narrowband signals. Natural processes create those broader band signals, but not the narrowband signals.
Right. So if you do see narrowband signals, then it's a hallmark of potentially
potential. That's the important word. Yeah, potential.
Extraterrestrial life.
Potential. Yeah. Either that, or we've discovered some new physics. We need to,
Right.
is there something that does naturally produce that? Yeah.
So, what were some? Because I'm interested in, because I was a big alien conspiracy theorist.
Right.
I think when I've spoken to my friends, a lot of my science friends came from like a conspiracy background.
Right.
They were like convinced.
X-Files, right?
X-Files, the Illuminati,
Yeah.
all of that. And then I think as they as they learn about the scientific method, they realize, oh, this is all nonsense. Or it's potentially really, really probable that it's nonsense. You can't really rule out anything.
Yeah.
But can you tell me more about this search for extraterrestrial life? So was that the only effort that was made, or were there other efforts that were made to actually looking for ET?
Well, I guess this is the only true scientific effort at looking for extraterrestrial intelligence. I guess that we come from the idea that travelling those vast distances is next to impossible, especially if you consider a human lifespan, let's just say 70 years. At the maximum speed we could go in 70 years, we're not getting very far. We're not getting even to the closest star. So,
what is the closest star to us?
Well, I guess that was a bit of a slip. The closest star is the sun, but
besides the
sun, besides the sun, as Proxima Centauri. So,
how many light years?
About 4 light years away. So,
okay.
If you travelled at the speed of light, it would take you 4 years to get there, and 4 years to get back. But there are certain things that happen when you travel at the speed of light.
Yeah.
So by the time you got back, everybody you knew, you would have aged 8 years, but everybody that you've known would have been long dead, and so on, because of the relativistic effects,
right,
and so on. But we can't travel at the speed of light because we have mass. So unless there's some other ways of moving through time and space that we don't know about at this stage, and there may be. Actually physically travelling to the stars is out of the question, which then others visiting us. Well, if they're that advanced, they're not going to be crashing in Roswell to have people do autopsies on them.
Right.
Yeah, so I mean, if they're that advanced, they're either here already, but they're so advanced we just can't detect them because we just don't know enough yet.
Right, or they haven't even come.
Yeah, exactly. Yeah.
But when I think about this, I mean, one thing that convinced me that ET hasn't arrived on Earth is, as you said, the time it would take to go from one star to the other 4 light years. That's assuming you're traveling at the speed of light.
That's right.
That's going to take ages if you can't do that. So obviously,
not in one generation anyway.
Yeah. So do you think it's more probable that if there is life out there, they'll probably send drones like things that we're doing to Mars? One
thing I hate to do is to try and second guess what if there is an alien another intelligence out there, what they would do, what their motives would be, because all we're doing is sort of projecting our own motives, and whenever we say what they could do, we're sort of thinking of the technology that we know ourselves. So what would they do? I don't know. Would we do? Well, yes, we'd send a drone. Effectively, we've sent a drone. We've got Voyager 1 and 2 that have left the solar system now. So effectively, they're like our first attempts at drones to travel into interstellar space. So what would they do? They might do that. Considering those vast distances, unless they're so far advanced that they do know how to control wormholes, they know how to bend space or whatever. They've discovered physics we haven't discovered. They operate in a different dimension to us or whatever.
Right. That reminds me. Have you ever watched Expanse?
No, I haven't.
Oh, you have to get into it.
Yeah,
it is so good.
Is it on streaming television?
It's on Netflix.
Expanse. I'll have to have a look at it. Okay.
Yeah. It's interesting because you raise a good point. It's if we're going to speculate what alien life is going to be like, most of the time I think we're just going to project what we think is going to be like. And I think there's a famous case. I'm not sure if this was a scientist back in the days or some radical thinker. He was speculating what alien life would be like on a different planet, and he essentially reached the same conclusion that it'd be exactly like us because of he made the
argument. 2 legs, 2 arms, and 2 eyes, and okay.
So that always that cracked me up. It just shows how how limited our imagination can be when we
Yep.
think about alien life. But in The Expanse, I bring that up is because they have this thing called the proto-molecule. Supposedly, this is come from outside of our own solar system,
Right.
and what it does, it takes your life force and turns it into a new life force. It's really weird, and like,
Right.
I recommend you should watch this.
Okay.
Obviously, it's not entirely based on science,
Yeah.
but the physics, actually, the spaceship,
Right.
all of that is based in science. So what they do is when they take off, they keep the acceleration at 1g,
Right.
and then when they get close to their destination, they turn the ship around and decelerate at 1g.
Right.
So you experience gravity
Right.
throughout the whole time.
Right.
So it's really fascinating, but I brought up because of that alien thing, almost like a contagious, I wouldn't even say bacteria, protomolecule that
Right.
can take over people's lives,
Yep.
or their physiology and their life force, and turn it into, take over, like they can manipulate physical laws, and that may be possible, considering that if there is a civilization that has that existed a million years, or is older than us, then they could potentially develop technologies that may seem magical to us.
Oh, absolutely.
Just
yeah.
like an iPhone would seem magical to someone from 1,000 years ago.
Not even 1,000 years ago, but yes, absolutely.
Yeah.
Yeah. So anything that advanced would seem like magic.
Mm. So in your honors, you worked on this,
Yep.
and then what did you do from there?
I was actually a lecturer, mostly teaching. So it was mostly teaching for a few years, and then
Where did you teach?
I taught at back then it was UW, University of Western Sydney, Macarthur. So mostly teaching in courses related to computing and engineering. So I taught digital communications technology, electronics, some computing, and networking, data communications subjects. So it was mostly teaching, a little bit of research on the side, and I think in when was it? 1997, I got the opportunity to travel to the US, to UC Berkeley, and I collaborated with a team there, who is the team who is currently doing the biggest SETI search in the world, and they're actually doing it partly here in Australia, thanks to a Russian billionaire, Yuri Milner, who's funded a project to target a whole bunch of stars, over 1 million stars, with the best technology we have to do a search for extraterrestrial intelligence. So I worked with them for about 8 months, built some equipment with them, bought that back. We used that at the Parkes Radio Telescope, and that was at the Parkes Radio Telescope. It was Southern Serendip until about 2007. And I then, about 2007, started my PhD.
Right.
So I did my PhD, and I did in astrophysics, as I said, looking at supernova remnants.
Thanks for listening to Blab Codes. Rate and review our podcast on iTunes or wherever you get your podcast, because it does help us spread the word. And if you like what we're doing here, then help us grow it by sharing this with a friend of a friend, or your mailman, even your mailman's mailman. We also want to hear from you, so send us questions or comments to blabcoats@gmail.com. And if you have any interesting questions or comments, then we'll talk about it on air.